All right. Hello and welcome, everyone. Actually, let me pull myself to the side here a little bit, and then I will do the other view whenever we bring Roy up. So, welcome to this month's basically the Trino meetup. We're going to be joined by a special guest today, Roy from Upsolver. And they're going to be talking about best practices for enabling self-service analytics in a data mesh. And so this is kind of a pretty cool topic because Trino in general is just one of these technologies that I think could be pretty I can't think. I know will be pretty foundational to kind of one day achieving data mesh. These days, it's kind of in that buzzwordy phase, and we're kind of not really sure about how data mesh will actually come to fruition. And so a lot of people just think, well, let's just throw out data mesh. We're just going to end up moving forward to data lake houses or going back to data warehouses. And I think that notion has kind of come because we kind of jumped into data mesh before the technology was there. And so Trino is kind of at one of those cool junctures where it allows us to get access to all of these databases. Currently thinking of just read access, but we've also heard people talking about how they use Trino as a security analytics security broker and enables all sorts of federated capabilities across multiple data systems. So it's kind of interesting to see how Trino could end up becoming one of these pillars to enable like these four foundational principles that bring us to a data mesh, which one of them is self-service analytics platform. And so I think this is kind of the on the line of where Roy's going to be talking about today. So I don't want to spoil it too much, but always really interesting to see like how Trino will kind of be able to slowly take off some of the pillars to be that technology that talks to across these systems and enables these different capabilities that Zhamak Dehghani, who invented or kind of was the thought creator of around data mesh, who was the one that was ultimately, coming up with these four principles. And so we're talking about one of these principles today. So if you're like, oh my gosh, I can't believe we're talking about data mesh again, just hold out and kind of check out these talks. It's not just trying to push on the kind of buzziness of it. It's really talking about what are one of these core foundational principles and how are we going to solve it using Trino. And so if you want to ask questions or reach out to us, you can find us at TrinoDB. Also, for the host of this meetup is Starburst Data, so you can reach them at Starburst Data and follow them there. And then also give us a star on GitHub, TrinoDB/Trino, if you use this technology and you love it. So, oops, I am clicking on the wrong screen here. Let me go ahead and move to our agenda. So we're going to do a little bit of community updates, talking about what's going on in the Trino community. And then I want to give a quick overview into what Trino and what Starburst is before we hop right into the meat and potatoes, which is everything I just kind of talked about with that whole best practices for enabling self-service analytics in the data mesh. So community, if you are not part of the Trino community, or if you are just now learning about Trino and you're trying to figure out what to do and how to get involved, I would say, number one best place to be is trino.io/Slack. You go to that website and you sign up for our Slack channel. We have a couple different channels that you'll want to check out. We have a beginner channel. And that will enter you into that and by default, and you can ask any question there without feeling silly or bad that maybe you didn't look something up. Just ask the question even if it's been asked before. We want to just get you up and running as quickly as possible. And then if you want to know more about dev, how to get started in the actually developing features for Trino, then you can go onto the dev channel. We also have a troubleshooting channel if you're already using Trino and running into some issues and need some help. So that's there. That's definitely first thing I suggest. If you want to learn more about Trino and just like see a couple of these like kind of podcasty or as we like to call it, the broadcast, because we kind of put it both in podcast and YouTube form, check out the Trino community broadcast. It's trino.io/broadcast. Has all the episodes of that we've done. I think we're about to do 41 in 2 days. And so we have a lot of cool topics that we talk about there, anything from the ecosystem to to what is Trino to different clients that even run on Trino. And so definitely a good one to get started there. You're here in one of the virtual meetups. You're in the Americas virtual meetup. We're slowly building out to different regions as we move on, and we're actually just now trying to get more in-person meetups going to basically get people even outside of Trino specific meetups to kind of become more aware that we have these Trino virtual meetups as well as in-person meetups that will be starting now that we're getting to a better time after post-COVID. So it's really exciting times. We're also going to, I don't know if I have a slide for this. I can't remember if I put it in or not, but we're about to have our first in-person Trino Summit. So if you want to learn more about that, actually, Anna, if you could drop a link to the Trino Summit registration, then in here, and then we can share that on there. So all of these links that I'm sharing up here, by the way, too, will be visible. Oh, excuse me. Let me see if I can bring this up here. So this is the Trino community resources that are available. And then for signing up for Trino Summit, you can actually, I'll pull up the link later whenever Anna gets it up. But there's another link you can go to register for Trino Summit. You can do so virtually if you're not going to be in San Francisco around November 10th. And I'll see if I actually have. Oh, there we go. Perfect. Here, let's do that one. There we go. So Trino Summit sign up, you go to starburst.io/info/Trino Summit, and that will actually take you to Trino Summit. Also, if you go, let me just exit out of the screen. If we go to Trino.io, Trino.io, and you go right here, there's this little thing on the front page that actually takes you to that same registration page. Learn more will take you to a little blog that I wrote, and check out this fun little teaser. It's a little bit of a Pokemon teaser that I have put in there for like a little commercial for the summit. So check that out, and then definitely register virtually if you're not going to be able to make it there in person. All right. And then finally, I also want to showcase, if you want to contribute to the project, go to trino.io/development. That takes you to a page that will show you how to get started in developing features and functionality for Trino. You can also learn about how to write blogs, look at some of our blogs in trino.io/blog, or there's another link that is in that master link I just showed you before, that will contain all of these links to join in the community. So, all right. Another thing I will push is the Trino forum. It's kind of a nice sidecar site to the Slack channel. We try to basically take a lot of things that are discussed in the Slack channel and move them and copy and move them over into Trino forum so that others can also find all of these answers that are happening on Slack on Trino forum, as well as people can directly ask questions in Trino forum as well, whatever your preferences. And so that's at trinoforum.org. So let's go ahead and move on to the next one. Oh, yeah. Okay, I am so silly. I didn't know if we had this slide or not, and we do. So November 10th, 2022, 9 a.m. to 5 p.m. PT in San Francisco at the Commonwealth Club, not Common Health Club. We'll have a Trino Summit live and be there in person. Roy tonight, who is also talking on the meetup tonight, will be doing another presentation there. And so if you're really liking what the kind of talk tonight, Roy will be doing a slightly more kind of internal view at how they use Trino at Upsolver for that one. And so it's going to be really exciting. This is also virtual. Again, it's a hybrid one, so we don't want to exclude anybody if you're not able to make it there in person. And again, to register at starburst.io and /info/Trino Summit. You'll get plenty of swag if you go there in person. You'll get some swag if you are there virtually. And if you are here tonight and you want to get a Trino shirt, you can go. This link is also available in that master link that we shared in the YouTube channel. So you can also go into that YouTube channel and or in the YouTube comments and find the links there. That was just shared as well by Anna. Let me pull that up again. Give me 1 second. right here. So that will be available in the chat on YouTube. So definitely go click on that link and check that out there. And with that, if you have any questions throughout the show today, you want to ask, you can interactively ask us on YouTube. You can also, which would be the best preferred method, because then we can actually bring it up like we did just those other comments. And or you can ask us on the Trino Slack on the general channel. Well, actually, we need to change that. There's no longer a general channel. You can ask on the beginner channel for this one, and then you can also ask us on Twitter at TrinoDB. So with that, I will do a quick introduction over what is Trino, what is Starburst, just to kind of give you all who are not familiar with the space what this is. And then we'll hop right into Roy's presentation. So Trino is a high performance MPP SQL query engine. It's able to basically do a lot with this. This is a lot of fancy, jargon to basically tell you that it's a super fast query engine that is able to split up a lot of these processes that, let's say, we're scanning some data in a distributed database, and we can now scan and pull in data to each of those nodes in parallel. We can also do a lot of processing and different kind of SQL operations, and anywhere where it's possible, where there's kind of a non-blocking element on there, we can also do that, across different threads, and ultimately split it up as much as possible, split up these operations as much as possible, so that we can effectively get that computation to run fast and efficiently. And there's also even down to the kind of bytecode, where we are kind of generating brand new bytecode every single SQL query that you run. So that is kind of at the level of optimization and why Trino is so fast. It's a community-driven open source project, so the code is all out there for you to look at, for you to modify in any way you see fit. And ideally, you take those modifications, you maybe add a connector or update the performance or caching capabilities of certain connector, and try to contribute that back. And then we are very happy to work with you on getting those merged in. And then, kind of the core philosophies behind a lot of these big data systems was to really not have, kind of those kind of like traditional RDBMS data systems of old, where, there was a vertically scaled storage solution mixed in with the query engine all in one. We really wanted to separate these compute and storage. And so Trino itself is the kind of compute segment of that. And it interacts with a lot of different databases that are essentially acting as storage, as well as sometimes in the case where you're dealing with like the Hive connector or the Iceberg connector. Those are where Trino is actually the core query engine that is interacting with some storage capabilities. So this makes it possible for us to actually do this kind of SQL on anything capabilities. You can actually run a join query on a table that's sitting in your Postgres table, and join it with some table that's sitting inside of a NoSQL database, like let's say Mongo or something like that. And you can join those two tables together. You can even join Mongo to itself, which is actually pretty revolutionary for people who are NoSQL, because they were told that joins are bad, and unfortunately you can't avoid them all the time. So this actually enables that use case where, in the rare case where you would need it, you'd be able to even do that. So deploy anywhere. You can deploy, Trino has a Helm chart, so you can deploy on Kubernetes. Obviously then with Kubernetes, you can deploy that in AWS on like an EKS type server, or you can deploy into the GKE for Google and all that stuff. And same thing with Azure, the AKS. So all of those capabilities, by running on Kubernetes, you can now do that in the cloud, and it's super easy to get a Trino instance up and running. Of course, this is something you can do on-prem, and we have now documentation to kind of go into that. So all in all, Trino is the biggest thing that it brings to you is the ability to have this standardized view across all these, disparate systems, these heterogeneous data sources that are SQL, NoSQL, data lakes, all sorts of things. And now you can have a consistent SQL, ANSI SQL view on top of all these very kind of complex DSLs and all sorts of different things that you can't necessarily always query on. Trino brings that one place where you can have that singular model to address all this data and merge it together and do all sorts of cool transformations on it. So what is Starburst then? Well, Starburst takes Trino and we add a couple different enterprise grade connectors to it, security, the performance and scalability in those connectors of ones that do exist in the open source. We've added a couple of things like that. We have a lot of the majority contributors and people who were originally part of a lot of people that were in Teradata and Facebook in the early days working on what was previously Presto. All those people have now come under one roof under Starburst, and now you're going to get that, the support from people. If you buy Starburst, you get a little bit of that support in the open source side. I'm always kind of sitting on Trino Slack trying to help people out as best I can, but you'll get people who are paid and who have dedicated time to focus on helping you out with your issues when you are buying into Starburst. So not going to talk about the rest of the stuff about our company. We're super cool, fun startup, and if you want to work for us and you think query engines are cool, you should work for us. But that'll be it for my pitch for Starburst. We have also one more thing. There's Starburst Enterprise, which was our original solution, which is kind of like on-prem Trino, but like Starburst style, has all the extra goodies with it. But now we have Starburst Galaxy, which is the SaaS version of that, which is just a button push. Literally makes deploying Trino like the easiest thing out there. You might think equivalent of something like Amazon Athena, but it's really just like has a lot better scaling, has a lot better cost models and things like that. And so definitely something to check out there if you want to play around with Trino and get started quickly. I believe we give some sort of like free credits for you to play with that. With all of that said, let's move this over to Roy Hassan. Man, Roy, you're gonna have to fix me on how to pronounce your last name. Let me bring you up here so you can school me on how to correctly say your name, so I don't screw it up at Trino Summit.
No, that's okay. You said it right. It's Roy Hassan. Makes it easy. Yep.
Oh, great. Okay, great. So Roy, I've always, I'm intrigued by the theory of data mesh. It's kind of annoying to a lot of engineers out there who ultimately are like, well, what is this buzz term that I have to learn again? And it doesn't seem to be taking off super fast, and I don't really see it affecting my job today. So like, I always get really excited though about when we do eventually have a lot of these like fundamental pieces that Zhamak Dehghani wants to lay out for us, like essentially laid out the framework for us, but we don't really have a lot of the core tech that's needed to implement data mesh today. I think Trino is one of those pieces, and I think that if we build the right building blocks on top of Trino, could be like one of the best ways to kind of implement a data mesh in my view. So I'm really excited to kind of hear about your perspective on at least one of those principles that Zhamak was talking about with the whole self-service analytics.
Yep.
So take it away, and I'm excited to see this.
Awesome. All right, Brian, thank you very much. I really appreciate it. Welcome again, everybody, to the meetup. This is kind of my first time doing this meetup. I'm actually excited to be presenting at the summit in a few weeks. Actually, it's not that far away. So the session that I wanted to present today is really around best practices for enabling self-service. Now, data mesh gives us kind of a framework, but like Brian said, it's not necessarily a technology or set of technologies that enable it. It's a framework that different vendors and different tool providers sort of took and adjusted and made it kind of work the way that they wanted to work to make it, offer the capabilities that it talks about. But what I wanted to do is kind of double click on that a little bit more today and kind of fine tune the specific kind of deliverables around self-service. Like, what does it actually mean, and how do we actually deliver it? And kind of look at a couple options of doing it and provide kind of an opinionated approach that we've been taking with Absolver and with our customers as well, and kind of see if that resonates. And please drop your questions. If there's any questions there, we'll be happy to take those actually towards the end as well. All right. So not spending a lot of time on definitions and things like that, but if you think about self-service analytics, There's different ways to look at it and kind of slice and dice that definition. But in my mind, when I think about it, when I talk to our customers, it really means the ability to give data users the ability to kind of build and iterate through experiments using data, but very quickly, right? Not having dependency on other people, not waiting for your data engineering team or other teams to get data for you and to iterate for you after you've given them their definition, give you that self-service, give you the autonomy, the ability to actually tweak and tune your experiments and do stuff with data in a much rapid way than you could have in the past. So when we look at it, it's not really that easy, right? As we claim it to be. Self-service is great. Everybody says, yeah, let's do self-service. Throw BI at it, throw this tool at it, throw this tool at it. It's really not that easy to do in reality. And there's just a couple kind of tweets that kind of set the stage and say like, hey, there's bottlenecks, there's problems, there's collaborations, there's different teams. Like you can't just say, ignore everybody else and do whatever I want. And that's something that I think with data mesh, when it first came out, there was kind of the notion of self-service. And when I talked to customers who read the blog post from Zhamak about data mesh, they kind of thought about, hey, but I want self-service, but I have this data team, I have this IT team. Does that mean I just get rid of them and I just do my own thing? Well, no, it doesn't really work that way. So what I wanted to do is kind of focus on that specific vertical and sort of give you an idea of how you can implement that using some technologies and as well with Trino. So data mesh, I'm not going to spend a lot of time on what it is because it's a lot of different things. Like Brian said, there's multiple pillars. Inside each pillar, there's a whole lot of other detail that we can get into. But what I really wanted to focus on is kind of the important part of decentralization of the data team and empowerment of data producers and consumers, right? And what that means is being able to create an organization or a structure of an organization within your company that both enables the producers of data to be autonomous and create their own data, but be responsible and own that data, but also enable the consumers of that data scientists, analysts, et cetera, to be able to iterate and experiment very quickly with data without depending on the data producer. So creating that decentralization within the company is the piece that I've seen being very, very successful with companies as a starting point, as an entry point into kind of the framework of data mesh and being able to leverage the rest of the pillars inside of data mesh. So what does it actually look like? This is a picture from one of the blog posts because I didn't want to spend a lot of time on explaining data mesh. If you want to spend hours on it, I'd be happy to do that and give you my opinion on it. But if you look at this picture at a high level, there's typically in an organization is this data infrastructure as a platform. So you may have an IT team, you may have a data team, and that team defines what that platform looks like. And then the rest of the organization can choose to leverage that platform because it's a standard set of tools that have been validated, configured, optimized, secured that everybody can just use, right? Or the different teams may choose their own tech stack. That becomes a little bit more difficult. And then you have these blobs, right? And each blob, you can think of them as a domain. And many times this is a domain that's in a larger organization that may be a business unit. In a smaller organization that may be different teams. Like in a microservices architecture, you may have your payment team. You may have your recommendation team. Each one of those teams has data sets that they want to share with the rest of the organization, where today it's kind of locked within that microservice, that database, or that set of compute instances that are holding that data. So how do we free that data? How do we make it accessible for the rest of the organization through sharing and through governance, right? And that's kind of the bigger picture. So let's kind of double click on what that is a bit. So how can data mesh specifically help us with self-service analytics? And again, the caveat here, we're only focusing on a few specific items. There's a lot more to it. So let's not get wrapped around, you forgot this, or there's more of that, or these kind of things. I'm trying to be very focused and very specific. So the first item is really this data as a product. And we hear this a lot. And data mesh didn't invent it, but it sort of, added more fuel to the fire of data as a product. And what it means to me, and when I talk to different companies, it's about providing reliable, accurate, and managed data sets. So rather than saying, hey, Roy is going to just create a data set, it's going to include, our revenue numbers and other sort of financial information, and is going to make it available to the rest of the organization, to the CEO, etc., to be looking at it. But then when Roy goes on vacation, or Roy leaves the company, or Roy maybe he screwed up the way that we calculate revenue, well, that's not really reliable. Like, how do I depend on that data? If Roy leaves the company, in a week or in a year from now, who's going to take ownership of that? How do we make sure that the data is actually accurate? So when we look at those dashboards, they're correct. I had a customer about a year ago that I met with them, and they brought me in after they had a really big problem. And the problem was that they had a data pipeline. They're producing a bunch of data for their finance dashboards. And about 2.5 months into that dashboard being live and reporting to their board and to the CEO, they realized that the numbers were wrong. They realized that they've been just producing inaccurate data, but nobody knew about it. Nobody knew it was inaccurate because nobody looked at the data. Nobody validated, nobody checked it, right? That's not reliable. That's not accurate. That's not really data as a product, because you would never do that for your product that you're offering to your customers, right? If a financial company, like Intuit offers a QuickBooks service, right, they're going to make sure that thing is accurate. They're going to make sure it's not producing any wrong data, right? We got to have the same rigor and the same control when we're producing data sets for our own company internally. We can't just make a table and say, okay, we're done, and now start, building our financial models around that and not realizing that, hey, maybe there's a problem there. So anyway, data as a product, really putting a lot of rigor and control and reliability around these data sets. The second point is around producer ownership and transparency. So today, when companies or when teams produce data, rarely is there full ownership and transparency about how the data is produced and who is actually responsible for fixing it, for the quality of it, for any kind of outages or any kind of issues that happen with the data. Many times the team says, my microservices has it in the database. I'm going to just do a dump into an object store like S3. The rest of the company can pick it up. If that dump stops for some reason, you know what? It's not a priority for me. We're going to deal with it later. Well, but it's a priority for the business when they're trying to make decisions off of it. When you're building machine learning models that have to keep being trained off that data, it becomes an item that somebody needs to pay attention to. So who's going to have ownership, right? And once they produce the data, you want some transparency into how the data is produced, how the data is managed. Give me statistics. Tell me, hey, is the stream of data actually live? Do I have dips? Do I have drops in events? Do I have spikes in events? How do I know what's coming and going? I can't just depend on somebody to tell me. I want to have some transparency and visibility into it. And then the third one is around data discovery and sharing. Now that you have these data sets and you have some ownership behind them, how do you actually discover them and also share them across the organization? You need some kind of catalog, some kind of way to say which data sets are available, which one can I access, who has control, who has permission to access what, but then also be able to share, because consumers can also be producers, right? So if I consume some data and I build something interesting out of it, I want to then share it with somebody else, but I want to do it in a responsible way. And then the last one that I talk about today is around consumer autonomy. So related to all these things, the self-service aspect of this whole conversation is giving not just the producer the ability to be responsible for producing their own data, being in control of their own data, but also the consumer, giving them the ability to consume the data in whichever way they want, whether it's Trino or Snowflake or Databricks or whatever. They want to have control over the ability to consume the data and do whatever you want, but also experiment and iterate very, very quickly, and then share those data sets in a reliable way with the rest of the organization, right? And that's the piece. Those are the pieces that I think Data Mesh kind of brings together around self-service. And these are the ones that I really want to kind of focus on and show you my point of view of how do we implement this, how do we see this in the market, and how some ways to implement that. All right. And I do tend to talk fast, so I'll try to kind of slow down a bit. All right, cool. So data is a product, right? There's lots of blogs out there, lots of content out there to tell you what is data as a product. But when I think about it in very simple terms, it's really about building these data sets with the same mindset and rigor as a product or service that you'd build for your company that is offered to your customers, right? If you would never put something out there that your customers will consume, you shouldn't be putting it out there internally for your internal customers to consume. So you got to have the same rigor, the same controls, the same processes in the same mindset around delivering these data sets as you would any other product. And we can get into what that really means, but in essence, when we talk about these data sets from a data perspective, one way to look at it is you want to have some common language that that product is built in, right? You typically don't have a product, even in today's world, that's built with Python and Java and Scala and some JavaScript and a whole mix, because it's very, very hard to maintain. So you don't want to have something similar where you have a data product that's using some Python functions and then Scala behind the scenes, and then you throw some SQL on top of it. It becomes very difficult to maintain as people kind of churn and people leave and move teams, and as the product grows and becomes more mature. So having a common language is much more possible. Going with SQL, yes, it has its limitations, but it's also a language that really everybody understands, right? It becomes easier. And when the addition of a little bit of Python to give it some extra power when you really need it, that's a great way to kind of have that common language and the ease of use when new users get onboarded into the data product. Data contracts, you probably heard a lot about this on LinkedIn, on Twitter. There's a lot of conversations around, like, what is a data contract? Like, what is this? Why do I need this? In reality, it's really about a schema and a set of quality definitions that defines sort of the data that the producer produces and the data the consumer would expect to receive, right? So if the data producer changes the number of columns or adds a column, removes a column, changes the types, the consumer needs to know about it in advance. They can't just randomly change it. Just like you wouldn't change an API signature, you're not just going to change your schema either. But in today's world, those schemas just change dynamically when new features get added or new data sets get added. But the consumers then have to deal with all that breaking changes. Dashboards break, models break, queries break all the time. We need to be able to do that. Like, one of the things you make sure with APIs is that if there's any real breaking change, there's lots of notice to your customers. You try not to do any breaking changes, first of all, but if there are breaking changes, you give your customers a lot of notice. You give them a lot of help to make sure that they fix their code, their applications, before you change that API signature. We need to have the same thing here with our data. Automation, be able to actually deploy automatically. Try your data product in your staging environment, then transition it to your production environment. Do testing. Be able to kind of automatically deploy and test without humans kind of interacting with it. Makes your data product much more reliable, much more resilient, and you can catch these problems or issues well in advance. Verifiable, again, that's something that when you're offering a data product, you want your consumer to be able to go run some queries against it. Go check it. Go check the availability, the resiliency of that data set, right? Is it going to be around? Let me query it. Let me understand if it actually does the thing that I want it to do, right? So you want to be able to verify it. It's not like I'm going to throw a data set over the wall and then you do whatever you want with it. If it works, it works. Good luck for you. Like, no, there has to be some rigor into it. Discoverable. Once you created this data product, however you present it, whether it's a data set inside of a data warehouse, whether it's a data set inside of your data lake or somewhere else, you need to make it discoverable. You don't want your users to go into Snowflake and then go into your catalog, Glue catalog for the data lake, and then go into your Trino instance, and then go into MySQL and keep looking for stuff, right? You want it in a single place. And whether that's through a business catalog or a technical catalog, doesn't really matter, as long as there's a way to publish this metadata into some kind of catalog that makes it easily discoverable. And then maintainable and scalable, those are the things that when you produce a data set, typically the data producer will just say, like, here's a data set, I put it inside of Snowflake, it's Snowflake's problem to scale, right? But who's going to maintain it? If something breaks, if something changes, who's responsible for maintaining it? And what procedure, what rigor do they have to maintain it in a way that's scalable for the organization? Because if that person goes on vacation or leaves the company, who's going to pick that up, right? And then lastly, it's cost effective, right? You need to be able to be cost effective, just like you do with any other product in your organization. You can't just throw a whole lot of data into Snowflake and then tell the users, hey, go ahead, just run queries on it, whatever you want, and then end up racking thousands of dollars for your company. You need to be responsible. So that's at a very high level, kind of like what my definition of a data product and what my expectations from your data as a product tool set to deliver, so your company can actually implement this in reality, scale it, manage it, and replicate it across the company. So hopefully this kind of makes sense. All right. So in a market, there's a lot of different ways to do this, and I apologize, I should have included Starburst in this as well. But kind of when you look at the market, you hear a lot about this kind of modern data stack, and this you see on the left side, and you can think about it as an ELT approach, right? And that's more of a batch process model. And typically, you have an ingestion engine like Fivetran that just moves data from a bunch of sources into a target, and the target is Snowflake. And then you have a modeling transformation engine like dbt that is then orchestrated with Airflow, right? So this operation is mostly a batch style operation that moves data in batches, transform data in batches, but then requires a lot of orchestrations around the scene, around all the stuff to make it work and make it tick. Right? It's one way to do it. It has its pros and cons. I won't get into too much of that. But that's one way to do it. Another way to do it that I've seen very commonly in the market with customers is an ETL approach, but it's still batch, right? A very similar model to what you saw with the previous thing, just instead of Snowflake, using Databricks, because Databricks gives you that transformation before the loading, but also the query ability to read the data. The main difference is that with Databricks, they tend to store the data in your data lake as well, not like Snowflake, where they store it in their own proprietary format. So it's a bit more open, a bit more accessible. So that's another model that you can see. I don't include streaming here, even though Databricks or Spark does support streaming, is because the model of Fivetran plus dbt and Airflow is a batch model. It doesn't really enable streaming in a streaming sense, right? You still need to run to schedule these Airflow things that run every so often. And as that frequency of runs gets shorter and shorter, the complexity of your Airflow orchestration becomes much greater. If you wanted to do streaming in this middle stack, you almost have to stand up in a separate environment to do streaming, because the batch environment is not as compatible with the streaming. So I end up creating like two complete environments that makes it very, very hard for users to maintain and to scale. And then on the right side, I'm showing you what Absolver does in this. And what we did was we really focused on simplifying this whole thing. So kind of bundling the transformation modeling layer with the orchestration layer into a single platform, so you don't need to maintain multiple pieces. Because as you deliver this as a product, this data as a product, it becomes very difficult for the team or the person who's building the data as a product to actually build it. Because in the first and second stacks, there's a lot of learning curve. There's a lot for me to learn. How do I use Fivetran? How do I use Airflow? Airflow dogs are not easy. You got to write Python. Okay, you can have some visual engine. They're not that great. At the end of the day, if you need to troubleshoot them, you got to dive into Airflow to troubleshoot them. dbt, it's great. It automates stuff. But you know what? It's SQL plus a whole lot of configuration that if I'm not a CLI person, I'm not familiar with those kind of processes, it's hard for me to learn. Yes, I can learn it, but it's more work to do. And then Databricks with Spark is great. But at the end of the day, if you build a pipeline and the pipeline breaks, or you need to troubleshoot something, you need to be a Spark expert. It's really not that easy, right? And then in the Absolver side, we're basically saying like, hey, there's no Airflow, there's no orchestration, forget about it, right? The transformations, the modeling logic is all SQL. You already know that. There's no heavy configuration and Jinja templates to do. Yes, they're cool. Yes, they're awesome for engineers, but for most common users, they're overkill. There are a lot to do and a lot to learn. So keep it very simple. And if you wanted to use Fivetran to ingest the data, you can, or you can use the connectors that Absolver brings. But then Trino on the top of that, it kind of has two models, right? You can either do the data mesh approach where Trino basically makes a connection, decoupled queries, where you can actually reach into these other systems and query the data directly. or you can have Trino kind of query the data directly in the data lake where everything flows in both in batch and streaming model. So again, those are just 3 kind of stacks or approaches to do it. And throughout the rest of the presentation, I'll talk about how they're different. And then I'll show you a demo kind of how we solve this problem with Absolver and how our customers are using this in order to deliver data as a product. So again, I want you to think about, as I talk through this, like the definition of data as a product, how easy it is to actually implement, and how can we make it simpler for more users, not just hardcore data engineers who really understand this technology and this tech stack. How do we make it available and accessible to more users by simplifying the stack, simplifying the different learning aspects that they have to pick up, and really make it accessible and self-service in that sense. All right. So one of the things that I wanted to kind of call out before I continue on this is we talked about the separation of these producers and consumers. And that's a really important aspect for us to remember, because when we look at the first tech stack with dbt and Snowflake, or even the second one with Databricks or dbt and Databricks, like in those 2 tech stacks, the producers and consumers are, they're not really separated. It's sort of the same person. Now with dbt, you can have separate folders that allow you to create different types of models, some for consumers, some for producers. But in reality, the way it's built, the way it's executed, the way it's managed is through a single entity. So you typically see the data engineers or the analytics engineers responsible for the dbt environment and for all the models and everything that goes with it. If you're a consumer, a data analyst, that want to go and build a model or build a transformation that's relevant only to your use case, it's actually a pretty high learning curve to be able to do it on your own. You have to really understand the whole dbt model, the way it works, the way it structures data. Or you become a Snowflake expert and you go build stuff into Snowflake. And if you do that, now you have this bifurcation of dbt and Snowflake, and it becomes really hard to maintain those things. The same thing with Databricks. When you go into Databricks, you're both a consumer and a producer in the same environment. There's no real separation. There's no encouragement of best practices in a sense of separation. So one of the things that we wanted to do with Absolver is we wanted to actually be opinionated about how your organization should think about the separation of producers and consumers, so each has more autonomy. And yes, they're talking to each other. Yes, there's a contract between them, but they can live independently. They can work independently. So the way that we handled this was through this concept of data source as a table. As you can see this thing in the middle. So we basically separated the producers and we say, look, producers, you're responsible for creating connections and creating these staging environments that allow you to copy data from sources, Kafka, S3, Salesforce, whatever, into your data lake table, right? The staging table. And then the consumer is able to come in and say, I don't care what the producer did. Like if I care, I can go look at it, but they staged my data. They got it ready for me. Now I'm the consumer. I can go read from that table, from that source, and I can go build my transformations and my models. And then I can load that data into my target, right? Whether into the data lake, into a data warehouse, or into other systems, you have that flexibility. So by the notion of creating these 2 types of jobs, these 2 types of instances, we separate the producer and the consumer. Now, if you wanted to, you can merge them all together and say, Mr. Producer, you do everything, right? You're the data engineer in this world. You can do everything. Or you can say, no, we're going to actually separate that. So let's kind of dive a little bit into what that looks like. So from a producer ownership and transparency perspective, one of the important aspects and one of the best practices that I've seen is be able to simplify how these producers are producing the data sets. So in a product world, the product guts, the inside, is not exposed to the user, right? To the end user, right? So if Intuit is building a service, the end user doesn't know how Intuit built it. That's their secret sauce. That's their own world. With data is a little bit different because the data is sort of the product itself. And when you're exposing it to your users, you want to give some transparency around how the data has been produced, what transformation is going through, what lineage did it go through? Like what changes it had? What systems touched it? So you do want to expose a little bit of the guts, a little bit of the inside, how the sausage is made to your users, because you want to give them that ability to verify and confirm and audit and make sure that the data is produced properly and it's viable for them to use it. So when you're looking at tools like Spark and DBT, the way that you build the data sets is quite convoluted. Like in Spark, is really flexible and it's great and it's powerful. But for an analyst to come in and say, I want to look at how you produce this data, it's actually really hard. You're sending them to go look at a bunch of Python code or Scala code or SQL code combined with Python. And there's multiple files because you want to compartmentalize it and you want to do different things. It's actually really hard. Like if you go and you're not a data engineer and you look at a code base of Spark, it's actually quite complex to understand what's going on, especially in the Java Scala world where there's classes and dependencies and stuff like that. Similarly with DBT, like when you start using it, it's fairly straightforward. You just write a couple files that are your SQL models, very simple. But now as you start evolving, you start using references. You start using sources, using views. Now all of a sudden, you no longer have SQL in your files. You have a bunch of Jinja templates or macros in there that are automating and simplifying things. But for the user, it's like super hard to understand. So now I got to know how to run the DBT stage and a DBT test. So it generates my data, the query for me, and I can go look at it. It becomes more difficult, right? So how do you make it more accessible to your users? It's really it's the core aspect, right? So Spark is great and powerful, but it's not that accessible to majority of your users in a company. DBT started as being accessible, but kind of evolved and expanded and added more and more and more, and now it's becoming less and less accessible. With Absolver, we wanted to be able to make sure that everybody understands what's happening. We kind of learned this lesson from from financial services customers that we spoke to, and the way that they build their data pipelines is they basically create different steps of the pipeline, and each step of the pipeline is actually maintained and managed by a different team, right? This way you have accountability. So if somebody by mistake or malicious use inserted some Trojan horse or some bug into the transformation that steals pennies when data gets processed or does something malicious, there's some accountability to it, right? So you may have 4 or 5 teams that develop different pieces of the pipeline, and they're experts at different areas, right? So we wanted to give a single view and an easy way for each of them to be able to validate, and for an auditor who comes in who maybe doesn't understand all this stuff, to be able to very quickly audit each one of those stages without having to learn Python and Scala and Java and DBT and Jinja and SQL, right? Make it easy. So the way we've done it is, but we basically say we kind of broke up all these stages into independent tasks, but they're all written in SQL, right? So it makes it very easy. The additional thing that we did was we kind of automated all the orchestration and scheduling of the jobs, because we treat everything as a stream, whether it's batch data sitting in S3 or something coming from Kafka. We treat it all as data in motion, right? So the user doesn't need to know, oh, it's batch, oh, it's streaming, oh, it's different behavior. It's all the same behavior. So there's no orchestration. There's no airflow to go figure out, did you run this job first or this job second? It makes the ownership with the data producer, but it also enables transparency for the consumers. So hopefully this is kind of resonating and making sense. It's not about just building something and then saying I'm done. Like, people want to validate. The users of your data want to verify and understand what you're doing. And it's important to have transparency. And we want to offer transparency by simplifying the way that we write the data and making it a more common language. Like we saw in the beginning when I talked about data as a product requires a common language to make it more accessible to users. That's one way to do that. Okay, so in Absolver, a product is called SQL Lake. We do it very, very simply, right? So a data producer can come to the product, and there's really 3 steps that they have to do to onboard new data sets. The first one is they create a connection. In this case, I'm connecting to a Kinesis data streams instance. I define the IAM role and the region it's in, and that's really all it is. The next thing I do is I create a table, and this is my staging table. This is where I'm going to save my raw data, right? Now, you can define a schema if you want it here, right? So you have a standard contract for that stage data, or you can say, you know what, for staging, I don't want to have a set schema. I want to be dynamic. So if my application team decides to add a field or something like that, I'm more flexible with that, and I can let them just do it, and I'll consume it. Now, the third step is now I want to create a job, and this job runs automatically once you execute it, and it copies from my Kinesis connection, specifically the stream that's called storefront events, and then it loads the data into my target staging table, right? So with these three statements, I ingested a new data set from Kinesis into my data lake, and there's no orchestration here, right? You're not seeing any DAG creation. You're not seeing any scheduling. You're not seeing any scaling elements in here. It's very, very simple. Now, if there's a spike in events, the system will auto scale to handle that spike, and then it goes back down, scales down as the event spike goes away. But it becomes very, very easy. So a data producer can create a whole bunch of connections that users can use, create a whole bunch of connections plus staging tables, and then those staging tables become available to the data consumers to consume. So that's a very simple way to do it. There's really not a lot of experience or learning curve here for users, as long as they know SQL. And it's very easy to understand. If an auditor comes around and want to say, hey, what are you doing? I want to understand how you're doing this. It's very easy to understand it right from this code. Cool. So the next part I want to talk about is around discovery and sharing, right? Discovery is something that we want to think about as we produce and we create these data as a product. How do we make them discoverable through some kind of catalog mechanism, right? We don't want to send our users to multiple places to go find it. We're also not computers, so we don't know how to discover APIs. We're users. We're people. We want to go into some catalog to give us some fancy UI. We can click and drag and sample and understand. We really want to have ability to search. We also want to have the ability to share data sets. That's one of the most powerful things about data mesh is you create these data domains, right? Each of the groups, right? Your finance team, your marketing team, your sales team, your payments team. How do they share data sets between each other? And then how do they discover them? So when it comes to sharing, which is a common use case inside a data mesh, especially when producers produce data and want to share it with consumers, there's a few ways to do it. And I'm just kind of highlighting the ones that I talked about related to the tech stacks that I mentioned earlier. The first one is with Snowflake, right? So Snowflake kind of popularized this idea of direct sharing to say it's a zero copy direct sharing, which means that I share the metadata from one Snowflake to another Snowflake, so users can find it inside a Snowflake. But once they actually query the data starts moving, right? So it's zero copy one, in the beginning. But once you're running a query, then it starts to copy data over. It doesn't execute the query on the target, right? But it's proprietary to Snowflake. You don't really have another way to access it. You don't have another way to explore it aside from kind of having a business catalog suck out all the metadata out of Snowflake and replicate into the catalog so you can discover there. So yes, it works. Yes, it's fantastic. But if you're in a Snowflake ecosystem, great. If you're not, it's really not that easy to do. In addition to that, Databricks also introduced this Delta Lake sharing. And Delta Lake is Databricks' Lakehouse table format that moves the data storage and the metadata into a table format. So it takes it away from the catalog and puts all that information inside of a transaction log, right? So that actually makes it harder to discover and understand these data sets. Now, on top of that, they introduced this sharing protocol that allows producers and consumers to share data sets, Delta Lake tables between each other. Now, it's open source, but it only works on Delta Lake tables. So I can't share iceberg tables. I can't share Parquet tables or other things. And my producers and consumers need to understand the Delta Lake sharing protocol. So it really works in a Databricks ecosystem, but is not as flexible, not as adopted by other engines. So it makes it more difficult to use unless you're, again, inside of the Databricks ecosystem. With Absolver, what we wanted to do is we wanted to kind of open that up, and we want to leverage the sharing mechanisms that already exist with your cloud platform like AWS, and we leverage something that's called cross-account sharing. So inside of AWS, when you have you have two AWS accounts, you can share resources between those accounts, and it's a very generic way. It's not tied to one vendor. So if I share a resource from account A to account B, Snowflake can read it, Databricks can read it, Starburst can read it, Trino can read it, everybody can read it. So we wanted to kind of double down on that openness instead of reinventing the wheel and creating a new protocol and a new storage mechanism. And I'll kind of show you what that looks like. Okay, so data sharing. Again, I said it's a really powerful capabilities, not capability, but an idea inside of data mesh that allows producers and consumers to share data between each other and kind of collaborate and across the organization. So the way we do this with SQL Lake and Absolver is, again, very simple, 3 simple steps. The first one is we create a connection inside of SQL Lake to a target catalog. In my example here, it's a consumer catalog. So if I'm account producer, there's an account consumer. I create a connection to that consumer catalog. I give it an IAM role. I tell it, what storage connection I need, because I'm going to write into their bucket as well. What region it's in. I can do it across region if I wanted to. I'm just giving an example of one region here. So I create a connection to the target catalog, and then I'm doing all the same stuff as I did before, right? I'm not changing anything different. What I'm saying is I'm creating a table, but in this case, instead of creating a table in my account, I'm creating a table in the consumer account. So now that metadata is automatically available in that consumer's catalog. So Trino and Starburst can read it, Snowflake can read it, Databricks can read it, everybody can read it. Users can go and explore that metadata right away. So as a producer, I'm creating that metadata, I'm making it available instantaneously inside the consumer account. Now, the next thing I'm going to do is I'm going to create a job. And this job basically reads from my producer catalog, my local catalog, my staging table, and transform the data. In this case, I'm not doing any transformation, just selecting all of it. And I'm writing the output into my consumer account. So I'm already moving the data to the consumer, but I'm managing this pipeline. The consumer doesn't need to know anything about it. Now, if they want to understand how that works, they can come back into Absolver and they can look at this and they can say, okay, cool, here's the job. Very simple. It selects from this table, from the source table, and writes into my table. How is this source table created? Sure, let me go double click on that table and I can drill down and I can understand how to do that. And I'll show you that in a demo in a minute. The other aspect that I want to call out is if you see in step number 2, I'm actually defining a schema. And you can think about this as a data contract. So by defining this schema, I'm telling the catalog on the consumer side, this is the schema you're going to expect. I'm not changing it. I'm not going to alter this until, if there's any need to change it, I will then redefine the schema, the contract together with you, right? So this defines a static schema. If a new column gets added into my source table, it doesn't come across, right? It does not get passed to my consumer and potentially breaks their pipeline. Now, Absolver goes a step further and say that if you define an order ID as a string, but for some reason the source data has order ID as a string, and then later for some reason it changes to a double or changes to an integer, Absolver by default will cast that integer or double into a string, right? So it protects the consumer from some type changes that happen on the producer side if the producer didn't catch those things in advance. So there's some protection here, but for the most part, this is a contract that we want to define. And this is a really important aspect of sharing that we want to encourage with customers who are doing producer-consumer model. All right. Moving on. So the consumer autonomy, one of the items that I talked about, kind of the benefits of data mesh, is giving consumer the autonomy to operate on their own, to bring their own tools, to be able to use their own technology to process that data. So maybe this picture is a little confusing, but what I'm trying to portray here is that on the left stack, right, the consumers can use BI, they can use, visualization tools like notebooks, etc. They have REST APIs, but because the serving layer of the stack on the left side is Snowflake, you're kind of limited to what Snowflake offers you, right? So your ability to consume the data in unique and different ways is limited by the capability of the one platform, in this case, Snowflake. right? You're also, as a data consumer, if you wanted to go build your own data applications, your own transformations, you got to understand the stack. You got to understand DBT. You got to understand Airflow. You got to write stuff in SQL. It's not very accessible and very friendly for most users, analysts, data scientists, business users, to go build their own data apps. So yes, there's some autonomy because you can create the data however you want, but there's less autonomy in a sense that it's very hard for you to actually build your own data pipelines and your own data applications. You're still depending on some data team to do it for you. Similarly with the middle stack, where yes, you have more options for accessing the data because it's not locked into a data warehouse. It's in a data lake that's more open. But with that comes more complexity, right? There's Scala and there's Python and there's SQL and there's Airflow and there's understanding Spark under the hood, and how to launch clusters and manage clusters and spot instances and things like that. So yes, on the left side, it's a little bit easier. It may take you a few days to get up and running. On the middle stack, it actually will take you longer. It's actually weeks, because you can build the very simple stuff, but once you start scaling and adding more data to it, things starts to break and things starts to become more difficult, and you got to become an expert to troubleshoot that stuff. And then on the right side, we really try to simplify that and focus on just writing in SQL, and we'll do the rest. And a combination of Absolver plus Trino makes that stack super simple because it gives you a breadth of engines or tools to access the data, but it's a single platform, an easy platform to just write SQL and build your data applications very, very quickly in minutes, right? As opposed to weeks, because you're not learning anything new. You're not spending a lot of time learning new technology or new ways to orchestrate or to write code or to do macros in Jinja and all those kind of things. So consumer autonomy is not just about tools. It's not just about the consumption tools, but it's also about giving the user, the consumer, a way to build their own and create experiments, build more data sets, do more, become the producer as well, right? And that's a really, really important point that we tend to kind of overlook when we talk about consumer autonomy and self-service, is that we focus only on the consumption part of the data. We don't focus on that these consumers actually want to be producers, and how do we make it easy for them to also produce. So let's take a quick example of how Absolver does this. So in Absolver, we kind of talk about these data apps, right? So in the slide that I showed you, where we have the producer on the left and the consumer on the right, the producer created a bunch of data sets, create a connection, some staging tables, maybe they share the table with us. Now as a consumer, I want to actually create my own data. Now, if they share the table with me, I can just query it, right? Trino will do it, not a problem. But if I want to produce my own data sets, right, I can use Trino as create as select. I can insert into, I can create these data sets, but they're not actual pipelines. They're not running constantly. I still need to orchestrate them. I still need to schedule them. So how do we do that? We actually come back into Absolver and rewrite that transformation. So the first thing we do is we create a table. And again, we define a static schema here as a data contract that tells us how we partition the data, what's a primary key, what columns we are defining. Again, we are setting a contract for our users. And then we create a job that basically does a select statement with the transformation. So this is a select statement that's very similar to the one you write in Trino, but we're actually implementing it inside of Absolver as a pipeline. The wrapper around that select query, the create job insert into, is basically an Absolver wrapper that says, take this query, now orchestrate and run it, right? Now, it reads from the source table. It may come from a completely different AWS account. It may come from a Kafka stream or a Kinesis stream or a database. For you as a user, it doesn't matter. Like if those things break along the way, your job here will basically pause and wait for those things to happen to be fixed before continuing to produce data. It's not just going to keep running and producing garbage. It's going to wait because it realized upstream something broke and I need to wait. As opposed to an orchestrated job with Airflow and DBT, it has no idea. It's going to keep running unless you have some failure condition in your Airflow flow that says check this first and then run the job. Right, so we eliminate a lot of that complexity, but and basically bundling it all into a single command that makes it super simple for you to use. So this is how customers or consumers can build these data apps. So each of these create job statements, you can think of it as a data app. It may do something simple, like produce an aggregate. It may do something much more complicated that joins a lot of stuff together, does some aggregations, unnest a bunch of data, transforms JSON objects, et cetera, and produce a table like, I don't know, for product recommendation or some marketing view or something like that. That can be an app. Now, Absolver is responsible for managing all that stuff. If anybody wants to see how it works, they can come in and they can do that on their own. So that's it. I'll jump into a demo quickly. I spoke a little longer than I wanted to. So let me just quickly jump into here. So in Absolver, I'm not going to spend a lot of time showing kind of what Absolver, the product, is, but this is kind of capturing the examples I gave you in the presentation in a more realistic manner. So the data producer, right, in this case, I'm just ingesting and staging. So very similar. I'm not using any kinesis in this case. I'm just creating a connection to my S3, and this is using the Absolver sample data. I then create a table. You can see I'm not defining any schema on it. I'm just letting Absolver, do the inference automatically. You also see here that I'm using a system column. The $ says it's a system column that Absolver inserted automatically. It's because I don't know if my data, my source data, actually has a column to partition on. And I don't want to go recreate my data and add a column to it. So by default, Absolver introduces an event date column that is the ingest date stamp. So I can just partition my data based on that. If I had a column in the data set that is I can partition on, I can just put it in here. But Absolver makes it easy for me. So again, this is encouraging best practice. And if you don't have that column in there to partition on, no problem, we'll give you one. So it's not, you're not going to say, oh, I don't have it, sorry, I'm not doing it. And then you're going to rack up a bunch of query costs, right? We actually encourage you by offering it to you. And then you run this job, which insert into, and I can just kind of quickly run this job. So behind the scenes, we kind of execute this stuff on a Trino engine, and you can kind of see that my source data has a bunch of internal system columns that you can learn from, but it has the raw data, right? This is nested nested JSON objects, not really easy to use. We have some timestamp. You can see the files, how long, when they were modified, the file names, file sizes. You can actually do some metrics and some analysis on your data and your table sizes and things like that. So now that the data producer created this data set, the data consumer can come in and actually use it. So in Absolver, we actually expose it through this catalog. So you can see here on this Glue catalog, we have the database, and then these are the raw data sets. So if you click on this raw data set, you can see here that we actually show you the events over time. So as events come into that table, we capture them here. So this is the observability. This is the transparency that I was talking about. So like, hey, I want to really understand how that table is loaded, how frequently. Did you have any events, any drops? How many times do you run a query against a table and you're like, hey, this table doesn't look right. Looks like I'm missing events. And then you have to go ask somebody, hey, did you guys have an outage last week or yesterday or last night? I'm missing events. You can actually go to the table, click on it, and you can see right away if there was an outage or not. You don't have to wait on anybody else. You can kind of get some field statistics as well. So if things change, right? If address or something change, you can actually see if there's a lot of nulls in the email column for some reason. You'll see the density here drop, and you can very quickly tell if you have problem with your data just by inspecting this screen over here. So that's kind of one way to do it. So once you have that data, you can also look at the columns. You can look at column by column basis. Where is it? So I think so you can look at kind of these columns. Let's go look at this one, for example. You can see the events that are coming in that include that column. So if there's a lot of events coming into your table that don't include a specific column for whatever reason, you'll see a drop in events. And you can go click on the column and say, hey, why is that column empty all of a sudden? Well, the event that's coming in no longer carried that column because it was reduced or it was dropped by the source. So you can identify that very quickly here. And there's a bunch of other statistics here that you can learn from. So again, this is a very powerful way to understand it. You can also look at what jobs are creating or reading from that table. So in this case, it's this particular job. So if I understand that table and I want to say, hey, I'm depending on this table, who else is depending on it? Who is writing to that table? I can actually click on this and I can say, hey, there's a create job, right? That's writing, that's inserting into that table. And it's really not doing anything, right? It's just reading from the source, which is from this bucket, this prefix, and writing into this target. But I also have this other job, right? This other job that's reading from it. Now I can see exactly how that job is reading. It's reading from it. It's inserting to another table. This is some of the transformations it's doing. Awesome. Now I can understand how that output table is built, right? So this is, again, the transparency and accountability that comes with the platform kind of by default. So nothing is done in hiding. Everything is available for users to go look. Now, as a consumer, now that I identified that there's this raw data table, I can go and I can actually build my own table. So in this case, I'm creating this orders transform data. Unfortunately, I already created this to kind of speed things up. I created my table. I didn't define my schema in this case, but you can if you wanted to. And then you have, this is my transformation job, right? So I'm inserting into my target table. I'm doing a bunch of transformations here. And then that's it. So I can run this job, or I can actually go preview this job, which would take a sample of data. Oh, I think see if I screwed up here. That might be just a little glitch. So I can actually sample my data here. We'll give it a second. That should hopefully work, unless I have a bug in my demo, and that's not uncommon in demos. So that's pretty awesome. But anyway, so we'll let this process. But anyway, basically you can kind of preview. You can preview the job before you execute it, and then once you execute it, you can actually, it outputs to a table, and then we can just rerun our query against that target table. And again, we execute this with our Trino engine behind the scenes, and you can see this is the data that was transformed based on the query that I execute here, right? So I see my customer ID, actually my order ID somewhere. I can see order ID. I can see my customer email. I can see all that kind of stuff. So this is the output that I created. So at this point, producer created some data, consumer created their own data, and now the consumer in this case wants to share that data with somebody else, right? So in this case, I'm creating a connection that will say, this is the bucket, and this is the IAM role that I'm going to use to write into that target account. I'm creating a catalog that will write metadata to the target account. And then again, I'm creating a table in a target account. I'm creating a job that selects from my source table and writes it into my target. And then just to kind of very quickly, if I go into Athena, this is my other account. I can kind of go and query. I'm sorry I didn't have this. I was trying to get Starburst set up. I didn't get that set up in time. But you can kind of see that I'm querying my data that was produced in my target account. And you can kind of see the data sets here. So that's pretty much it. I know that I talked about a lot of stuff, but I'll stop here with a quick summary. And if we have any questions, I know I didn't leave a whole lot of time for questions, but we can do that now.
Hi, awesome. Thank you so much. It doesn't look like we have any questions, but this will be streamed on, or it has been streamed on YouTube, the Starburst YouTube and the Trino one. So yeah, there's all that information there, and this was great, and we're looking forward to seeing you at Trino Summit very soon.
Awesome. Thank you very much, everyone. Thank you, Brian. Thank you, Anna. Really appreciate it.
Thank you.
Thanks, everyone.
Bye.
Bye-bye.